Yeah, hi everyone, and today we're going to take a look at, let's say, a sorting method known as merge sort. Obviously, I just have a bunch of code here, just based and to help us with the sort. But before anything, I just want to talk about the general idea behind the merge sort, or at least the logic behind. Well, let's say we have a small data set right over here as my array, my integer array, of course, using C language. And what we're going to do is we're going to split this entire array into two parts. Let me just make it even for the sake of the video. So we got the first four elements, you split it out, your first half. Then you can take the rest of the four elements, split it, then you have your second half. And previously, I think we took a look at uh, several other forms of sorting where we sort only a particular set of elements, then gradually, progress moving forward. But the idea with merge sort is quite similar, but we'll dive a little deeper. Just based on the first half of what we're again going to do is split the first half again by half, meaning you're going to have half the number of elements. So I'm just going to call it 1.1 maybe. Yep. So you're going to have another split which is 1.2. Similarly, based off of the second half which we have split from the original array, you're going to have two parts, meaning we just call it 2.1, the second half being 2.2. Essentially, from the original array, we have come down, split them enough to a point where we have four different arrays which are split. I mean, technically, we could stop and kind of work our way here and just sort these elements, just the pairs, and move on. But when it comes to merge, what we're trying to do is split it again. So based off 1.1, we're going to split it down to the very last minimum that's possible. Meaning what it will be left with is, let me just call it 1.1.1. The other element being, of course, the next 1.1.2. Similarly, you can work your way with these guys as well. Meaning, with the second, you will arrive at, let's say, 1.2.1. I'm just giving random numbers, you don't have to worry about it, just to make sure that we're on the same page. So 1.2.2. Similarly, we can split these four elements into their own separate arrays. But the quality of these arrays are meant to be sorted, meaning that this particular element is sorted by itself in its entirety. Once these elements of, let's say, the minimum possibility being just one element, they are sorted within their own existence. So we move back up. So you come right over here and you can compare just the pair of elements. Meaning, let me take 1.1 as an example. You have 38 and 27. I can compare 38 and 27 and place 27 right before 38 solely because it's smaller. So I've just sorted 1.1. Similarly, what we could do is essentially go back, or let's say move on to 1.2, and 3 is smaller than 43. So I'm just going to sort just the 1.2. The next being your 9 and 82, it's already sorted, but regardless, once you're done with comparison, you're going to end up with the same array. The same applies to 2.2 as well. Now you have four sorted arrays which you're now going to combine back, meaning you're going to work with these two arrays and sort again. So let me just work with this particular data set. Meaning if you're going to work with, let's say, 27, 38, 3 and 48, essentially what you're going to do is just sort this particular array. What we have done, similar to what we have done with until the very minimum case to where it is right now. Of course, it will translate to a point where it's 3, 27, 38, if I'm not wrong, 48. This should be, one of the first halves that we started with. But on the flip side, you also have these guys to worry about, meaning you're going to sort 9, 82, 10, and 11. So you're probably going to end up with 9, 10, 11, and 82 just for this particular array, meaning you're with your second half that we began with. I'm just using references for our sake. And obviously, you're going to compare the first half and the second half and sort exactly like we did. And then you arrive at your result. Meaning you can come back up, take a look at this particular piece of code. All that I've done over here is just create an array, created the size of array keys, and printf, meaning you're going to work with the original array, whatever. But what we've essentially done is call merge sort. So it goes right over here. What this particular piece of code does is it's going to find what's mid. As we have done right over here, we're going to find whatever that's middle over here. Let me just make it, for the sake of video, an even number to make it easier. Once it's done, the mid is going to right now be 4, roughly about that case. But once you have 4, now it comes to merge sort this particular case. Meaning, what we're trying to do is we need 2 parts in order to merge, similar to every other case over here. You cannot have one piece of array and then work your way up. So you need 2 different pieces to split, as we have done over here, first half and second half. So from the very beginning until the middle element, you're going to create or cut the array by half. Whatever is left from the middle to the rightmost element will be the second half. That's exactly what we've done here. So from 38 until 3, where your mid is, that's your first. From whatever is left after the middle element until the end is whatever is left with you in terms of second half. Then you move forward and call for merge. But regardless, the merge sort is going to get recursively called over and over and over. Let's say I'm at my second recursive call. But in this case, what's going to usually happen is the fact that, of course, it's going to split again. So while it's the second time to run, you're going to have 4 elements when it comes up until this particular 42nd line. So similar to what we've done over here, this would be the array that's getting worked up with, but this version is just what we've done after sorting. But the first half is getting split into exactly these pairs of elements. So 1.1, 1.2 is getting made right over here. But that's 1.2 is after another recursive call. But regardless, your 2.1 is also getting made, meaning this is my first half, the array is getting, recursively called, 38, 27 being the first pair being split, 43 and 3 will be split again, but 9 and 82 is also getting split, and 10 and 11, so on and so forth. The process happens over and over and over until you stop with the least that you can do with, which is 1 element. That's where you set your limit, meaning left, the number that holds or the value that left holds should always be lesser than whatever in terms of right. We're talking about limits for this particular case. Let me take up this particular case. The left could have been probably roughly from the very minimum, but you're crossing the limits in this case. Left would turn less than the required amount, but you move backwards, and you can also take a look at merge being called. At some point, the merge sort function will not recursively be called over and over and over. We'll move on to merge at a certain point where it's getting called, meaning it comes up with these elements. Well, it's one single sorted array, even if it's a single element. But to make sure we are on the same page, we'll talk about at least pairs of elements. Let me talk about 27 and 38 being called in that particular line. We provide the value that is on the left, the middle, the right, the entire array for reference. So let's work with 27 and 38. You come over here. Essentially what's happening in behind these lines of codes is we are creating a copy of the arrays, as I mentioned, and we're going to merge the arrays into essentially the original array, what we're working with, as you notice. Of course, if the element is smaller, it's going to get the initial attention which is placed on the left hand side. If it's greater, obviously it has to get placed in the right hand side, meaning exactly what we've done. So it was 38, and if it was just 38 and 27, 27 was lesser, or 38 was greater, meaning it should be placed at the right hand side, and 27 was smaller, it should be placed at the position where 38 is. This process is done, but there could be remaining elements in the process which we're just trying to handle right over here. Again, we're not going to return any values. These are here just for reference, and this process just continues, happens over and over and over and over again. I agree regarding the piece of code. My suggestion or my intention is solely on just getting the logic right. It doesn't matter, solely because it's just a piece of language and syntax put together in a seemingly simple manner, as you guys can notice. So that's where my focus is. Just let me know if there is really great emphasis on line by line, word to word, point to point, syntax to syntax kind of attention needed, because I've also noticed a few of my friends requiring that kind of help. And do let me know where there needs to be improvement, and please be helpful and try to provide some suggestions. It'll be absolutely great to hear something from you guys. And this should be your merge sort, practically it. Thank you.